This is A2Further maths, and it's further partial fractions. You should all be familiar with regular partial fractions from normal A2 course, but in further maths we need to deal with it whenever there's a quadratic factor in the denominator. Now, there's plenty of times when there's a quadratic factor in the denominator in regular maths, but you can always reduce it down into two factors. But the one we need to deal with here, if it's non-reducible quadratic factor, for example, x squared plus 1 can't be split into its two linear factors, so in that case we need a new method for that. And the way we do it, if it's a non-reducible quadratic factor in the denominator, is we take the x squared plus 1, and down here, instead of an a and a b and a c, we do ax plus b if it's non-reducible. And that's pretty much our format from there. So let's take a wee look at our first example and we'll see how we get on. So we have 5x squared plus 4x plus 4 all over x plus 2 upon x squared plus 4. First thing we always do now, anytime we do any partial fractions, should be to check that the degree on the bottom is greater than the degree on the top. The degree on the top is a quadratic. Degree on the bottom, hopefully you can see, is going to be a cubic. Once you times your linear by that, we're going to have an x cubed term there. So we're fine then to get going with that. This x squared plus 4 is non-reducible, so we need to split it up then as follows. So we're going to write, in fact we'll just do it up here. So that's going to be a over x plus 2 plus, and this is our new bit, bx plus c all upon x squared plus 4. Rewriting this line out here, so I'm going to need to multiply top and bottom of this one by x squared plus 4, top and bottom of this one then by x plus 2. So we'll do a couple of lines here. So we're going to have a upon x squared plus 4 plus bx plus c, which I'm going to need to stick in a bracket because I'm timesing that then by x plus 2, and that all over x plus 2 upon x squared plus 4. That means then we can equate our two top lines. So equating the two top lines, then we will have 5x squared plus 4x plus 4 equals ax squared plus 4a plus b x squared, let me see, what are we going to have, plus 2b x plus c x plus 2c. If we let me see, x equals minus 2 would be a decent place to start, I think. And they can nearly cheat by looking kind of back up on the top line here. If I let x equals minus 2, on this side, you can hopefully take my word for it, you're going to get a 16. On this side, if I let x equal minus 2, you can effectively look up here. If I let x equal minus 2, this will be x plus c, but it's just going to disappear. So minus 2 squared is going to give me 4. 4 plus 4 would give me then my 8a. And that gives me then that a is going to be 2. There's other things you can do here, but actually our easiest way is to equate coefficients. This might be a new method for you, but it's straightforward enough. But the deal is, if we have an x squared over here, the only thing that can affect this x squared are the x squareds on this side here. So this 2bx can't affect the 5x squared. So we're going to equate coefficients then from here on in. So if we equate coefficients of x squared, that means on this side 5 is going to be equal to then on this side. So where's the x squared terms here? A plus b. We know a is 2, so in that case we know then that b is going to be equal to 3. If we equate coefficients then of x, so what are we going to have here? We're going to have 4 on this side. Where are our x terms? That's not an x term, that's not an x term. No, so we're going to have 2 b, and we know b is 3, so it's 2 upon 3 and then our other x term is here, plus c. I hope that makes sense to you. And then that c then is going to be minus 2. Just incidentally, you can check your constant here to make sure this wee system works. So we've checked x squared, we've checked x's, and then for the number term is a 4 here, and 2 c's are going to be here. So that's going to give me a minus 4 plus the 4a, which is 2. So it'll be 8, take away 4, which is indeed the 4. So that means it is correct. That's fine. So we're pretty much there, I think. So our final couple of lines in. Therefore, our question 5x squared plus 4x plus 4 all over x plus 2 upon x squared plus 4 equals, our a is 2 over x plus 2 plus our b is a 3, so it's 3x minus 2 all upon then x squared plus 4. So that's our first example. Let's take a look then at example 2, and we'll move it back up. Express minus 2x minus 1 all over those two big things in partial fractions. First thing we always check is the degree of the denominator. That's going to be the part forward and the bottom, and up there is the linear, so we're all okay with that. One of these is reducible, so we can factorize this first one here, so that'll split up into its factors. So let's do that first, and then we can rewrite it. Again, I'll do a wee cheat here. That's the same as minus 2x minus 1 all over x minus 2 upon x minus 1 upon x squared minus x plus 3. So how are we going to write this in terms of our partial fractions? That's going to be a over x minus 2 plus b over x minus 1 plus cx plus d all over x squared minus x plus 3. Let's leap a few lines. I hope we're at the stage now where we can do this. So we're going to have then minus 2x minus 1, which will be our left hand side. Here on the top we're going to need to multiply our a by this and this. There's a bit of writing here. Plus b upon x minus 2, so I'll write a bit smaller, x squared minus x plus 3 plus cx plus d upon x minus 1 x minus 2. I fitted it in. What about that? If I let, what am I going to do? I'm going to let x equals 1. That seems like a reasonable thing to do. If I let x equals 1, this is going to be minus 3. This whole thing disappears. This whole thing disappears. I end up with this. And if you let x equals 1 in that, we are going to have a minus 1 there. 1 take away 1 plus 3, so it's minus 3b. That gives me b equals 1. If I let x equal 2, that means this whole term will disappear. This whole term will disappear. If I let x equal 2, I get minus 5. And that's a 1 there. That gives me 5a. This gives me a value then of a equals minus 1. I'm going to then equate coefficients of x cubed. So we can work this out hopefully without multiplying the whole thing out. Look at the x cubed terms over here. There aren't any. X cubed terms here, that x times that is going to be that, so there's going to be an a. That times that's going to be an so there's going to be a b. The d, whenever you multiply it, it doesn't get multiplied by this x, so the d is just going to be x times x, so that's just going to be an x squared. There's going to be no d term in the x cubes, but cx times x times x is going to give me a C. And I can use those two there. So my C actually in this case then is going to be 0. Once I sub in my 1 and my -1 into there, they cancel out. And so C is 0. And the last what we're going to do is we'll let x equal to 0. That means -1 is going to equal, right, if that's 0, that's -1 times 3, so that's -3a. If I let it equal to 0, 0, 0, -2, -6b. If I let x equal to 0 here, actually the c bit is going to disappear. So that's a 0 there, that's a 0 there. The -1 times the -2 is going to give me a 2. And so it's plus 2d. If I sub in my values there, what do I have? B is 1, that's -3, A is -1 plus 6. And I take this over then the other side to kind of get my 2d and divide. I get a value of d equals 1. So that's me pretty much there. My original question was therefore -2x minus 1 all over x squared minus 3x plus 2 upon x squared minus x plus 3, and that equals -1 over x minus 2, because that was my a, plus 1 over x minus 1, and then the c term is 0, so that wee x bit there is going to disappear, so plus 1 all over x squared minus x plus